Alrighty. Okay, so today is Happy Pie Day. House Robber 4. There are several consecutive houses along a street, each of which has some money inside. There's also a robber who wants to steal money from the homes, but he refuses to steal from adjacent homes. Okay. The capability of the robber is the maximum amount of money he steals from one house of all the houses he robbed. Capability. So maximum of money he steals from one house of all the house. So there's like a maximum amount that the robber is capable of. Like maybe he can steal $10,000 out of any given home. Okay. You're given an integer array nums representing how much money is stashed in each house. More formally, the ith house from the left has nums at I dollars. Okay. You're given integer k representing the minimum number of houses the robber will steal from. It's always possible to steal at least k houses. Okay, so he's gonna steal k. He's gonna pick k houses to steal from, and then return the minimum capability. The minimum capability of robber out of all the possible ways to steal at least k houses. Return the minimum capability of the robber out of all the possible ways to steal at least k houses. Interesting. So I guess if you see a house, you have to steal everything from it. Okay, so like the house has some amount of money and the robber is only gonna steal from houses that has that or less amount of money. Or his capability is, I don't know, if he has a high capability then he can steal from any house, but he's not going to be able to steal from houses that are higher, that have more money than what he's capable of. Okay. So here he's stealing from 2 houses, so he needs to be capable of 3, right? What? There are 3 ways to steal from at least 2 houses. He steals at 0 and 2, 0 and 3, and 1 and 3. Oh, he refuses to steal from adjacent houses. I forgot about the constraint. So yeah, so there's only 3 pairings that are non-adjacent. So 0, 2, 0, or 1, 3, and 0, 3. And of those, he needs to be capable of at least stealing a 5. So the non-adjacent pairings would be like, well, 2 and 1 is the smallest, so therefore he steals from 2. Okay, needs to steal from the smallest. I'm pretty sure I'd done a previous house robber one, but I think that one was trying to maximize how much you steal. This is trying to minimize how much you need to steal. Almost certain this is dynamic programming, which is definitely not something I am too strong about right now in terms of my technique for it. Let me think. So, huh. So you're gonna find k non-adjacent houses and you're trying to minimize the maximum of those k. Minimize the maximum of those k houses. Interesting. Interesting. So I think what we can do is go through all the houses, and at each house it's either going to be we stole from the previous house or we did not steal from the previous house. And then for each of those possibilities, it's going to be, for each of those possibilities, there's going to be some number of previous houses that we've stolen from and the kind of minimum amount of that. So this is definitely dynamic programming. So we're going to keep track of two kind of possibility sets. Set one is we go through all indices, house spots, keep track of two possibility sets. At that spot, one is stolen from previous house. The other one is not stolen from previous house. And then for each set, track the least each set for each value of houses robbed. Let's say this is j smaller than k. Let's say robbed is r smaller than k. The smallest amount, track the smallest capability required to rob those R houses. Those are previous houses. Okay. So we'll have a dynamic programming array for let's see, robbed last, and dynamic programming array for no rob last. I'll just say rob last and no rob last. And rob last. This rob last, no rob last. And I think that should be 0 for every value from 0 to k. So that's k plus 1. This is also 0 up to k plus 1. Okay, so for each index in range of nums, let's say the house, the home value, is equal to Okay, the home value is equal to nums at I, or nums at index. And so the index, how to work with this index. So what do I look at? So if it's possible to do I need to keep track of more than this? I feel like I should be able to just keep track of just this and go down the line. Okay, so maybe I should start with -1 as a way to differentiate it from actual possible values. Like -1 is just an arbitrary, it hasn't been encountered yet. Um, so for each house, I'm going to look to see if the if the if I can improve on a previous set of k values. So that's a little rough because I can't keep track of it with a single number, I don't think. Because if, let's say I rob 2 houses, let's say I rob 2 houses, and I see another house. How would I tell that this next house improves on my 2 house? I guess the lower amount should be on the smaller one. Or so let's say you have houses that are 3, 1, 4, 1, 5, 9. So, and let's say k is let's say k is 3. So looking at the first one, if that's all you know, then well, technically you wouldn't be able to steal 3, but and let's assume for now, assume just the best 3 that you want, which is if you just want the best 3, then just creating the minimum of 3. So okay, so let's say k is 3. So if you just steal 1 after seeing 1, then you steal 3. If you just steal 1 after seeing both of these, you steal the 1. You wouldn't be able to steal 2. If you steal 2 after seeing the first 3, then you have to steal 3 and 4. And if you steal 2 after seeing the first 4, then you would steal 1, assuming that 1 is not one that you look at the best. You look at the best one that you stole from the if you didn't steal from the last house. Okay. Alright, I think this might work. I don't. Well. Yeah, I think this works. Let's see. Let's keep on going with it. So how to do this? For each, let's say total in Rob class. So it should start with it should start with some handling of the default values. So it's the total, what should the total be? Can't start with 0 because that would mean that your best thing is maybe I should just set it to be maybe I should just set it to be Boolean? No. For every total, I can set it to be the first house. So if you say that if at the first house you say that stealing from okay, I think maybe setting it to be 0. You rob 0 houses, rob last of 0 is 0, and no rob last of 0 is also 0. So the index within these two is the um, amount of houses that you robbed. And if you robbed 0 houses, then you burn 0. Okay. For each robbed, num robbed in the range of k plus 1. So if the num robbed is 0, I think maybe in the range of 1 to k plus 1. Because there's no, it doesn't make any point in trying to determine the best outcome for 0 robbed. So for each possible number of houses that you want to rob, okay? And maybe this should actually be a large number as the default. So for each number of houses to rob, if, let's see, does it improve to rob this house? So that question is, does it lower the amount in this array? So let's assume that we robbed the previous house. If we rob the previous house, well, let's start with assuming that we didn't rob the previous house. So we can rob this house. So if not robbing the previous house where we previously robbed num rob minus 1, if this home value is smaller than this home value smaller than if the maximum between this home value and robbed and not robbing the last one where we robbed one less house is smaller than uh smaller than what? We need to update something. Okay, so if we robbed some number of previous houses, right? Let's say we robbed, let's say K is like 100 houses, we need to rob 100 houses. If we robbed, let's say 49 previous houses, and whatever the capability required of robbing those are, plus robbing this house. So this is like the 50th house. The capability required of robbing all 50 houses would be the maximum between this house value and what the maximum was for the previous ones, or the capability required for the previous ones. And if that capability required is smaller than what you need to rob 50 houses where you robbed the last house, like this is technically robbing the last house, is smaller than robbing the last house for this number robbed, then rob last of this number robbed is equal to that new value, home value, active home value, and not robbing the last one. Alright, so we've robbed the last one. We updated that. You also need to update the no rob last of for num robbed. So no rob last would mean that, yeah, so if we didn't rob the last, if we robbed the last house, let's say rob last for any given number, then that can now be the update for the no rob last for that number, because let's say if we rob 50 previous houses and there's some capability requiring that, and we don't choose to do anything with this current house, then that could be the best answer for not robbing the last one, given that we've robbed that number. So no rob last or num robbed, and rob last or num robbed. So yeah, if we rob the last one, it can update, assuming we didn't do anything with it on this house. Is that all I need? I think that might be all I need. And at the very end, we just return the maximum of either robbing the last one for K houses or not robbing the last one for K houses, because in either case, we've robbed K houses. I could also use this -1. Unterminated. For each index in the range of length of nums. Oops. Say n is length of nums. Nums is not defined. Don't say name nums. Hums is not defined. Home is not defined. The maximum of the home value. Excellent, excellent. Don't return anything. Interesting. Let me just go ahead and just print out what the arrays are after doing this. Wow, that's no good. If the home value, if the maximum between the home value and no rob last, so when when the number robbed is 1, this maximum between no rob of 0, which should be 0, and the home value, which should be like 2. And that should make it so that it's smaller, no? And therefore it should store it. So if 2 is less than rob last at k is 1, which is infinity, that is smaller. Say print flag. It must not be hitting this. No, it does hit the code. Okay. Then why didn't rob last of the num robbed is equal to the maximum between so it's updating it. Wait, I never store anything to the no rob last. This should be no rob last. No rob last for this amount is equal to no rob last for that amount, or if you rob last. Okay. Okay, that slightly improved it. So it made this thing into 2, and then what did it do here? So it updates the rob last as long as it's better, and then if the no rob last at 1 is equal to the maximum of the rob last at 1. Oh, yeah, this is always just gonna be infinite. So what did I actually intend here? I intend it to be the min here. Yeah, there should be the min, the smaller of the two. Interesting. If you didn't rob the last one for k amount, and that was the best one that you could do, I feel like I'm so close. So okay, let's go ahead and print these things after each loop. Index loop um, after house index home value print rob last array is the rob last print no rob last array is the no rob last. Okay, that is not really what I wanted. I didn't want to actually fill these. I only wanted to fill one house. Didn't want to fill more than one house. I think I need to do an upper bound here. That's not k. So at any given point, the number of houses that you rob should only be, so you can only rob like one of the first two houses, and by the index 2 you can rob 2 houses, index 3 you can rob 2 houses. So you should only go up to the number of houses that is your index divided by 2 plus 1 up to the minimum of your index divided by 2 plus 1 and k plus 1. So if you're index 0 or 1, you're only doing this should go from 1 to 2 in that case. So this is not quite right. I think it's supposed to be plus 2 here. If you're at 0 or 1 index, you should go up to 2 as the range here, 1 to 2, which means that you rob one house. And if you're from 2 to 3, 2 to 3 is going to divide by 2, so it'd be 1 to 2, or 1, 2 to 3 divided by 2 is 2 truncated. 2 to 3 divided by 2 is 1, plus 2 is 3. So your range of houses that you can rob is from 1 to 3. Okay, I think that might have solved that issue. All right. So this one worked fine. After the first house, your rob last array is 0, 2. Your no rob last is also 0, 2. I feel like it should be at 0, 0, but okay, whatever. After the second house, it doesn't really change anything. After the third house, you should be able to rob 2 now. So yeah, it's 0, 2, 5. After the fourth house, it's still the same. Okay, after the first house is 0, 2. Second house didn't change anything. Third house you can rob 2, and your best is going to be 0. It's going to be 9. Fourth house, it should be now 3. Now that's the issue. You can't just go from, well, no, this should not be, it should be, I see. You changed the first house to be down to 1, and then that changed the second house to be down to 1. It should be looking at this house and setting it down from here to 1 here. And then I think this isn't, it needs to go in reverse order here. It needs to go from the maximum number of houses that you can rob down to the minimum number of houses, because it's possible to, I think it's possible to corrupt the previous accounting. So let's go from the maximum is going to be maximum be min index divided by 2 plus 1, that or k. Like the maximum number of houses is going to be that, down to not inclusive of 0, going decreasing. Okay, maybe that doesn't corrupt the, okay. So after 3 houses, it's 0, 2, 3. And after the fourth house improves, stealing from 3 houses down to 2, and stealing from 2 houses down to, or stealing from 2 houses down to 2, stealing from 1 house down to 1. Okay, I think that might. Alright, let's see what this does in the bigger tests. Too slow? That's the wrong answer. You steal from one house, it's going to be 35. You steal from two houses, it's going to be 9. You steal from three houses, it's still going to be 9. And if you steal from two houses within those three, it's going to be 18. The 78 is not going to change anything. There still should be 18 if you steal from 2, and 9 if you steal from 1. Wait, 18? That's not right. If you steal from 2 houses, this should not be 18, it should be 35. Because it has to be 35 and 18 at that point. Why is the no rob last after the first int house? Why is that 9? That should be 35 still. So if we rob the last one, so at the first house, I think this is just reverse order. I should be updating because I update the rob last to include this house. I need to not. I need to look at that information to update the no rob last first before I do that. Before I actually make changes to rob last. Okay, so still doesn't work. Somehow made it worse. Okay. Wonder if I should fix this one or this one. Let's fix the simpler one here. So 0, 2. If we rob the last house, if we didn't rob the last house, maybe one of these initial starting conditions is wrong. Let's see, what makes sense? After the first house, the best of rob last should be 2, and the best of no rob last should still be infinite because we didn't rob any houses at that point. And then after one house, the best of rob last should be 2, and the best of no rob last would be 2. I guess that's fine. If we do the third house, which is 9, the best of rob last, stealing 2 is going to be, 2 houses is going to be 9, yeah. And then not stealing 2 houses is going to be infinite. Or stealing from 2 houses, or not stealing from 2 houses, or stealing from 2 houses but we didn't rob the last one should be infinite because there shouldn't be a possibility there. Okay, and then the third one, or the fourth house, is going to be, if we rob the last house, including this one, the best is going to be 3. And if we didn't rob this last house, then the best should still be best should be 7 here. The no, not robbing the last house, the best there should be 7. Huh. Nah, this the best there must be 7 or 3. So robbing the last house is 3. Not robbing the last house. That should be infinite. That should be. Oh no, that should be 9. If we didn't rob the 3, the best that we do is 9. That's right. And then at the 4th one, the best of robbing the last one would be 1. Should be 2. Oh shit, this should be the minimum. No? Not the maximum, the minimum. How did my code work on the previous stuff? Jesus. Limit exceeded. That's a lot of houses. Okay, it's 3,400 houses. 400 houses. Interesting. Huh. I wonder. Am I supposed to just use a heap? Am I just supposed to use a heap? So the current speed at which I'm doing this would be n times k. You have n numbers. You're going through each number once in your outer for loop, and the inner for loop go through that k times approximately each time, like maybe 2k. So if n times k, O of n times k is too slow, then you need to do it in log n times. It doesn't seem right. Either that or I'm doing something. Time limit exceeded. Doesn't seem that. Actually, how big is this? It's 10 to the 5th numbers, and k can be roughly, basically, k is proportional to n, so this can be like n squared at this point. Interesting, interesting. Maybe I can try a greedy approach. If I were to sort if I were to sort the what if I tried a greedy approach? If I were to sort it, I would still need to keep track of which indices I've used so that I don't steal from adjacent indices. So I don't think sorting it works. But if I don't sort it, then it's basically, it should have to be at least n. So it's not n times k, but it's just like n and a fixed amount besides not k amount. Do I just need to keep track of when I robbed the last one versus didn't rob the last one? Doesn't feel right. Whether I robbed the last one or didn't rob the last one, I need to track how many I've robbed, right? For the maximum that I've robbed, down to the minimum. So this thing's always going to go through k. Is there a shortcut? I guess if no rob last is equal to the minimum of no rob last, that number, and robbing the last for that number. Alright, let's go. Say I do this at most 100 times, and then I return negative, just as a demonstration of this works in this test case. Up to 100 times, so maximum or the minimum between, no, the minimum between 100 and the actual length of this thing. Right. The first one, I'm just going to print out just the first 100. So rob last, say, yeah, whatever. Oh, this thing just doesn't print out that much. This updates it. No rob last, no rob, super no rob last. This thing and the rob last for this thing. if this thing is smaller than if the maximum of this thing and stealing from one less smaller than or if there's some check that can do to see whether or not this thing is an improvement. Is there some check I can do? I can quickly determine whether I can discard looking at this home value. Good. N is we're looking at 34,000 houses. Yeah, 34,000 houses. I guess if the home value is there some constraint, or can I logic that the homes that I steal from have to be within the bottom 2K number of houses? Like, is it possible for me to steal from, let's say there's 10,000 houses that I steal from, or no, let's say there's 10,000 houses and I'm stealing from 100. Is it possible for me to steal from something that's bigger than like the 200 smallest cells? I think it's like in the worst case, all like 100 houses I want to steal from are kind of clumped. In which case, I should be stealing from like one of the 200 houses, one of the 2K. So maybe if I determine that threshold amount, I can just discard looking at any houses that are above that threshold amount. So let's say that sorted houses is equals to I think it's sorted nums Python sorted. I think that returns me a copy. It's a new sorted list from the and then lowest value is going to be like I'm going to ignore anything above this value. It should be nums or sorted houses at 2 times k. So if I steal from more houses, If k is 4, then up to the 8th index. So 2k minus 1 or 2k. If I steal from one house, then I'm looking up to the 2nd index. So 2k minus 1. So then from 2 houses, I'm looking up to index 3. And so how would this work? Home value is that. Can I just skip over the lowest value? I skip over the lowest value, but if I skip over the lowest value, then I should still update this now. If I look at the bottom 2k houses, bottommost 2k houses, those are the ones that I'm stealing from. And then, can I actually just iterate through them? So like for each one, I steal from them. And if the next one conflicts, then the conflict is, okay, let's take a example here. So let's say it's 3, 1, 4, 1, 5, 9, 2, 7. So let's say I steal 3. So that means that I'm looking at the bottom 6 are candidates. So 1, 2, 3, 4. So there's 8 numbers here. It's just not possible for me to steal the 9 and 7. The only ones that I really worry about are the 3, 1, 4, 1, 5, 2. And if I steal 3 from them, then if it's a number that's bigger than, so is a number that's bigger than 5, there's just no world that I steal from it. So if I look at the bottom 2k elements within the houses, and I could possibly even truncate the array to just take into account those. The question is, how do I keep track of adjacency at that point? Or like when I say skip over 9 or skip over 7, how do I change this num or this rob last and rob last? So if you skip over a number, then automatically, I don't think you need to do a min check. Certainly don't need to do this check here, but that doesn't take a long time either. Because it does affect adjacency. Like theory, this was a big number here. Let's say this is 8, or let's say this is 9. Your bottom, what was like back here? Your bottom 6 are still 3, 1, 1, 5, 2, 4. But the 9 allows you to pick both the ones before and after it. So if you just skip it, you might consider the ones are not possible to be included in both. 2 or 3, the bottom 6 are candidates. So if you were to take the bottom 6 and pluck out just the smallest k, could look at for each number for the smallest k values, you add into some sort of set what indices it resides at, and then if you see a conflict, then by which I mean if you look at a particular small number and check what index it's at, if either the neighboring indices are already within this set, then you skip over it. It doesn't quite work because if your number was like, if all your small numbers go together, right, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you look at 1, you add that to the set, or let's say the 2 and 1 reversed. You add 1 to the set, and then you look at whether or not you can add 2 to the set. You can't because it's adjacent to 1, and you look to see whether or not 3 is in the set. You can't because it's also adjacent to 1, so you skip over 2 and 3 and then you like do 4. Then that doesn't work because technically 2 and 3 are better. So what if you started from the high one? Let's say you started if these were your smallest, I'm trying to find the smallest 3. So you start with adding the 6. And then you see if you can add the 5. You can add the 5 if 5 is not really adjacent to 2 things. But 5 is adjacent to 2 things, what happens? Add the 6. You add the 5, kick out the 6. You add the 4, kick off the 5. You add the 3, kick off the 4. Not really adding new things at that point. Start off with the bigger half. And then try adding a smaller. Start with something that has 4, 5, 6, and then each of the smaller ones than that. You pick off bigger ones. This seems a little too greedy. Lowest K amount. Both all your indices. Has to be some number that's near. Has to be some number within this set. Within these bottom 6. Technically, the bottom 6 can be duplicated. There could be some tires. But what if you kept track of a heap where you look at a number and that would still be n log k rather than n times k. So if you have a heap of size k, let's say you kept track of 2 heaps where you either robbed the last one or didn't rob the last one. And heap size k, and then each time you added say each time you if you had a heap for all the index in the range of n, the home value is the numbers at this index, you push onto the heap if the home value is smaller than or equal to the lowest value. And you will rob this house only if you didn't rob the last house. How do you prevent yourself from robbing the last house? You keep track of 2 heaps. A heap where you robbed the last house and you didn't rob the last house. Heaps. Oh god. A heap where you rob the last house versus a heap that you don't rob the last house. So what would that look like in practice? So the bottom 6 here, the smallest of those is 6. So I see a 2, add that to my heap. I see a 1. Can't really add that to my heap, right? I mean, I could, but then it's adjacent to something already in my heap, adjacent to the last thing in the heap. So 2 heaps, the rob heap and the didn't rob the last house heap. So my first one, I didn't rob the last house, and I'm robbing it now, so the rob heap is now 2. And not robbing the last house is still 0. Still empty. Alright, after that first loop, then on the second loop I'm dealing with 1. Then robbing the last house. Not robbing the last house. I add 1 to it. Add 1 to it. And 2 becomes not robbing the last house. Great. Do I need to keep track of the heaps? What if I just kept track of a single number? Yeah, what if we kept track of a single number? And that single number is going to be can't really keep track of a single number, right? Is that single number k somehow? Like if I steal from the last house, okay. So if it's a valid house, the whole value is below the threshold value, or the limit value, I guess, ceiling value, which is based on the lowest value here. If that number is valid, then that number might change. Value smaller. So if I stole from the last house, we can keep track of a single number, right? Has to be like, let's say the bottom 6 were arranged in 6, 6, 1, 2, 3, 4, 5. So I look at the first two. Like ideally, if I say I steal 3, then I would steal 1, 3, 5. So if I look at the first two, look at the first one, I steal 6. Look at the second one, I steal 1. Look at the third one, I steal 6. So 6 becomes, I didn't rob the last one, becomes 2. If I did rob the last one, I steal 2. And 1. If I didn't rob the last one, I steal 1. And then the third one, that becomes, it still seems like I'm keeping track of an array rather than a single number. But at least I don't actually do everything in the array. So it's the array is bounded instead by n, it's by k. So it's like k squared rather than n squared. Or instead of n times k, it's k times k. I wonder if that works. I guess so. But these things aren't necessarily next to each other. So when they're not next to each other, then the no rob last or that num. When is the no rob last ever bigger than the rob last? This code right here only occurs when I rob the last one. And I don't need to do that when the home value is bigger. Okay. What if I did this? Skipped last is equal to false. If the home value is bigger than the lowest value that I need, then I'm going to skip last is true. Continue. So that means I skip this index. Otherwise, I look at this index, I update this. I would automatically update this. and I don't need to worry about whether or not it's adding with the no rob last. Because it could be adding with the raw blast. It doesn't matter. Value if I skip the last one. And the max between this one value and robbing the last one. For num rob minus 1 is less than rob last. Then rob last num robbed equals. So I don't really need to keep track of two things if I skip the last one. Value rob last of num robbed minus 1. But if I didn't skip the last one, then I need else if skip not skip last. Then I just do that. So I skip the last one. And I don't worry about whether or not I rob the last one at all. But if I didn't skip the last one, then I do need to worry about that. Okay, let's see if this is still working. Lowest value is 2K. So K doesn't have to be every other. So the maximum, the minimum between this value and n minus 1. So whichever one's smaller? The last one in the array or 2K minus 1? I get what I got. Rent sorted houses, rent lowest value. Oh, whoops. If I didn't do this, then I don't need to skip. So I say skip last is false. All right, too much printing. give me too much output. Let's go and just delete this test case. Go back to printing some debug code here. Alright, so the sorted array is 2, 3, 5, 9. The biggest one to consider is 9. Okay. So home value is never going to ever be bigger than those values, so it's never actually going to skip anything. So this code should always work like the previous code, right? Skip loss is always false. So it's always just going to hit this code. Home value, and the last one is smaller than the last one. Okay, 0, 2, 0, 2, and then by the number 5, then 0, 2, 5, and then by the number 9. Oh, right, I had that return -1 thing. Alright, see if this thing works in this instance. Like, it should be faster, but still might not be fast enough. Well, that took a really long time to finish that. But we'll see how worse this technique is compared to other solutions. Time limit exceeded. So this test case is bigger, but it's basically a really big test case. Yeah, so it just crashes or it just doesn't finish on this big one. I wonder if there's a way, if I sort it and go through the bottom K, just go through the bottom K elements. Can I on the fly determine whether or not I want to include or not include some value within the list of houses that I want to rob? So is there some guideline? Like, I know I'm gonna rob, let's say 3 houses. Again, let's say the houses was worth let's say there's another 2 here. So the bottom 6 houses are gonna be 3, 1, 1. I'm gonna rob 3 houses. So K equals 3. The bottom 6 houses will be 3, 1, 1, 2, 5, 2. 3, 1, 1, 2, 5, 2. And I know I want to rob 3 houses. Three houses. So if I see something bigger than 5, I can ignore it. So I look at 3. So looking at from the algorithm, I know my threshold is going to be 5, or my upper bound is going to be 5. I'm going to say 3 is fine. I look at 1. I mean, 1 is less than 3 if I steal one house. So I steal 1, and somehow I know that I can't steal both of them. Now I look at the next one. Somehow I know that I should only be able to steal the other 3 and not the previous one if I were to steal 2 houses. And here, if I were to steal 2 houses, then I should know that the previous one is the best one. And then 5, I should know that the previous 3 is the best of that. Based on the index I'm at, I should know how many houses that's possible to have stolen from. So if is that true? Base amount is not true. Because if these are all spaced apart, then I could have stolen from every house. If there was like 9 between all these. And the bottom 6, 3, 1, 1, 2, 5, 2, they're all possible to be stolen from. So the 5 here so up to a certain point, I just have k houses I've stolen from, and the next house can either lower that amount or keep it the same. No. The next house. So for each house that I am looking through, I'm going to steal from that house and increase the amount of houses that I've stolen from. Steal from that house and increase the amount of houses that I've stolen from up to k, and then after that I can up to k, That's not true, is it? So like if I have 3, 1, 1, here I stolen from one house, the 3 or the 1, and so I need to steal from either from the 3 or the 1. So if I steal from 3 houses, like the worst they could be would be 3, 1, 2, 3. Or let's say it's 1, 1, 1. 1, 1, 1, 2, 3. So we're stealing from one house, it's 1. Stealing from one house, it's 1. Stealing from 2 houses, and there's still 1. Oh my lord. How do I know? What do I know? Okay. What's the hint? Can we use binary search to find the minimum value of non-contiguous subsequence of value of find the minimum value non-contiguous subsequence of a given size k. We use binary search to find the minimum value of a non-contiguous subsequence of size k. So find the smallest value so are we picking what k might be? And going through the array and seeing if that works. So if we choose an arbitrary value, say that that's the minimum value, then is it possible to go to the array such that you count the number of elements? I see. Okay. I guess it's binary search instead of dynamic programming. Find is possible. Some min value. For every home value in your nums array. Robbed is equal to 0. If home value is less than or equal to the min value, robbed plus equals 1. Rob last is false. Rob last is true. Sorry, if I guess here, since you're always picking the first one that's possible, then you just see if it's staggered. if rob last, then rob last is false, and continue. Rob last is true. Actually, let's say if not rob last and home value is less than or equal to min value, rob last is then just rob this thing regardless, and rob last equals true, else rob last equals false. So if we didn't rob the last one and this is something that we want to rob, then rob it, otherwise say that we didn't rob the last house. Okay, low is 0. If robbed is less than or equal to k, is greater than or equal to k, and return true if that's return the number of robbed is greater than or equal to k. Okay, the low number of houses, or the low value is 0, and the high home value is going to be the maximum of the array. I feel like there should be a better way than the maximum, but then while the low value is less than the high value, the mid values can be low plus high of 2. That is, let's say P is possible to steal from this. If it is, if P, then you try to steal from some higher amount. Oh, it's mid plus 1, else high equals mid. And then I think you should return the high. Well, let's see, if it's possible to do low and high, it should be always possible to do at least 0. But if it's possible to do mid, it's possible to do mid, and you go to mid plus 1, that might be impossible. Do you want us? So mid plus 1 might be impossible. But then at that point, it's going to be low is equal to high. Alright, let's just try this out. Well, at least it didn't go timeout. Interesting. Are these indices? Indices, right? Rent, low, mid, high, P. Yeah, this thing actually takes a long time to test cases. Huh. I wonder why. Like, it's not going infinite. So, tries out the 4. It's not possible. And then it tries out, oh, wait. If it is possible, then you go to a bigger amount. It's not possible. Can you steal from logic must be wrong here. The full value is smaller than equal to 4, then it's so you shouldn't be possible to do 4. So if it's not possible to do 4, you need to go higher. If it's not possible to do 4, you need to go higher. Okay. Oh my lord. Was that it? It was just not binary search at all, or wasn't dynamic programming at all. Okay. I feel like there could be a slight optimization here. Maximum of the nums. I wonder if you can do like that one. Is it better to sort? Sorting is n log n. Whereas if you just sorting is n log n, where if you take the maximum as face value, then you're gonna do one pass at the largest value. Do one pass at the largest value. Huh. Um, so let's say there's a large amount of values, like 50,000 values. And of those 50,000 ranges from 1 to million. Even if you do a million as your first high, it becomes 500,000 your second high, and then 250,000 as your third high. Is that better than just figuring out where the breakpoint is? So we're doing a pass through, robbing the last, but not robbing the last. I wonder if there's an optimization here. If robbed last and the home value is less than or equal to the min value, robbed last plus equals to 1 plus equals 1. Maybe there might be a quicker way of doing it like this. While the index equals 0, while index is less than n, where n is the length of nums. If min value less than or equal to min value, then robbed plus equals 1, index plus equals 1, otherwise increment index by 1. Okay. Don't need to keep track. So I just skip over indices. Otherwise, I just move on to the next index. I think this should still work correctly. Home value, if the home value, which is the nums at this index, it went slower. Really? It went that much slower? Try it one more time. Yeah, I guess the for loop is just incredibly fast in Python. It went just a lot faster. So how interesting. If you didn't rob the last one and the home value is smaller than rob plus equals 1, I think you can just say rob last is true. Yeah, I think that's fine. I guess if you do another condition check whether not robbed is greater than or equal to k at any point here, I guess you can do a small check here, like if robbed is greater than or equal to k, then return true here immediately. And then return false here. See if that shortens it just a little bit. That didn't shorten at all. That really didn't shorten at all. This was 80 something%. 80%ish. What did I do wrong here? Yeah. This statement's going to be raw upgrade. Okay. There has to be some other thing I can optimize here for. Low starts at 0. I guess. Where that I want to use, that's its capability. Maybe this should just be min of nums. Because you should always be able to steal from k objects where the minimum is the lower bound. Okay, slightly faster. Alright, just do a quick check here. What if I actually did sort it? So let's say S nums is sorted nums, and I actually used the high value based on that. S nums at 2 times k minus 1, the minimum between that and n. N is the length of nums. Next out of bounds. 2 times k minus 1 or high is or n minus 1. I think this should be a lot slower, but okay. Well, sorting seems to be pretty fast then. Yeah, I don't see how this goes much better. Alright, let's do a cheat here. See how the fastest solution goes. So find min and max in the list directly. So okay, you get the sorted list. After you do the sorted list, turns out so this looks the same for every one value. And if you've taken the previous one, taken equals false, count equals 1, count, break, taken equals true. I think the logic there is the same. I thought this actually slowed it down, but maybe somehow this doesn't. This looks identical. And pretty much everything. They did make this into a list. So they made it into a set, and then they sorted it and then they made it into a list. I'm not sure why this would be anything different than just doing sorted on nums. Sorted list of the sorted set. Like if you do, instead of sorted nums, do list of sorted of a set of nums. I don't see how this is any faster. Unless I'm not comprehending how this works in Python. Oh. They made it into a set so they ignored duplicates. Oh. But if you ignore duplicates, then how does so you make it into a set. What does that really give you? What's the benefit there? What's the benefit there? You're using a binary. Is left, right the actual indices and not the actual values? Oh. So you're using the indices of the sorted set to determine what values to search for, rather than just picking out all the values. Okay. Alright, the logic there, I don't know, it's something of incremental improvement, right? I'm not gonna worry too much about it. Okay, so in summary, do I even care for that improvement? I don't think so. Alright, so in summary of algorithm. This is use binary search to determine optimal capability value. Using a method that checks if some arbitrary value, in this case the method's called isPossible, can steal enough houses. And then change search range depending on if it's possible. If it is, try higher, otherwise lower. Alright, so like if you see if you're capable of stealing something like for a max value of 5, then if that's possible, then try searching for like a higher value. If not, then try searching for a lower value, and then eventually the range becomes 1. Here, time complexity should be O of n for is possible. So for any given value, to check to see if it's possible, so you're doing a linear walkthrough of your nums array, and then the actual search is O of login for search. And so overall, since you're doing for each time you're doing the search, it doesn't is possible check, then it's going to be O of n log n. Yeah, it's O of n log n. I guess that's not clear enough. N here is the size of the array, and this n is actually the search values, the range of values. So let's say O R, where R is the range of values. So it could be from the minimum value to the maximum value, which technically is 10 to the 9th. I mean, it doesn't take all that much difference between 10 to the 9th and 10 to the 5th if you log n. That's like one search, right? 10 to the 9th, or 10 to the 5th doubled is 10 to the 5th doubled is 10 to the, well, I guess it's not 10 to the 10th. It'd be like a factor of 10, I guess. So maybe that code sample of changing it to be, this one is actually n log n. This is n log r. But whatever. Space complexity, this is just just O1. This is constant. You're really not creating any other outside variables besides some integers. I guess you are. You don't really need this sort of thing.